Hi folks, so in this question here what we're going to do is we're going to complete a question from the Leaving Cert DCG higher level paper from 2022, and it was question B3 on that based on the topic of the oblique plane. So it says here, I'm just going to zoom in on that there now. The image on the right shows a Microsoft Surface Pro. It consists of a touchscreen and a kickstand. Figure B3 shows the plan and elevation of this touchscreen and touchscreen ABCD of a similar Surface Pro. So you can see here we're given down here the elevation, we're given the plan view down here. Part A, draw the given plan and elevation of the touchscreen. So they're kind of guiding us through it. Now, just a little reference here. They've given us the dimensions of the touchscreen, saying obviously A, B, C, D has a height of 60 and 60, and then 140 down to A, 240 long, 60 and 60, and so on, an angle here as well. Now, we also have to note that we are given a scale, and the scale is 1:2. What that means is that we're going to take every dimension and split it in half. So 60 and 60 will become 30 and 30. 140 down to point A will be 70. Angles will stay the same. 240 becomes 120, 60 becomes 30, 60 becomes 30. Okay, so we're going to have to start at part A, draw the given plan and elevation of the touchscreen. So to start off, just to explain there, and where we're going to start, point A is going to be our start point. We're going to measure down from the XY line. We're going to pick a point here, A. Okay, we're going to measure down 70, and then we're going to do an angle there, that line there, and that angle there is going to work out at 35 degrees. Now you have an angle here where it is going B here, and it's going off at 35 degrees. But using a little bit of maths, we can actually see that this angle will also end up being 35 degrees. Okay, and we're going to measure a line then, and we're going to mark 60 millimeters along that line, and also mark the 30 as well. Okay, so that's what we're going to do to start off. So, starting off with an XY line, roughly in the middle of our page. Okay, something like that. And from that XY line, I'm going to mark down 70 millimeters. Probably should have started a little bit higher, but we'll see if we fit it. It may just fit on our page. So about there, I'm going to start it. And then the point on the XY line, that's that point there as well. So down here, this is position A. Okay, so I'm calling that point A there. Now that I have that, I'm going to use my protractor. And from point A, I'm going to do an angle of 35 degrees. So reading it upside down, or sideways I should say, 35 degrees. I'll draw that angle in now. There we go. I've got my 35 degrees, and along that line I'm going to measure 60 millimeters. I'm going to mark the 30 into the middle and the 60. So I've marked the 30 and the 60. Now what I'm going to do is I'm going to project perpendicular to that. Okay, I can do it multiple ways here. I'll do it like this, using my set square. Just the camera there so you can see my little setup. So putting the long edge of the 45 degree, or sorry, this side of the 45 degree on it, slide it over. This one also works. So like this, into the middle, that one, and down to this one. Okay, and the length of it overall altogether is 120 millimeters. Do it from the top one. I think it'll just fit on my page based on where it fitted the XY line. Okay, now that I have that, I'm going to extend these guys just a little bit further. Okay, and now that I have that, put it on it there, slide it all the way across. Let's adjust this guy as well. It just fits on my page. So quite happy with that. So there is my plan view completed. I'll have it in now in a minute. But all I'm going to do now that I have the plan view is I'm going to project it up to the elevation. Probably should have put my XY line a touch higher. Actually fine. Seems to fit in the page just fine. Okay. So there is that one. This one. And that one there. Just extend up some of them. Okay, now I have a height and the elevation of 30 and 30, so from 10 up as far as the 13 and the 16. After marking those two heights, put a line across, draw a line across, and I can connect those up then. That will be the elevation. Now, really quickly, now that I have that drawn, just going to use my marker to heavy it in. Just comes up a little bit clearer on the screen for us. Obviously, on the day of an exam, you just be heavying this in with your pencil. So get this edge. So there's my plan view, just about done. Get a hidden detail here now as well. Okay, and the exact same up in the elevation then. Okay, and there is our elevation completed. And once again, sorry, just put in the. Now you just get marks for doing that alone. Okay, and last thing I would always do then is I will index. So A, B, I've got C here and D. Now if I was to label those, that would be A, up to B, down to C, to D, and then I've got the line running across it, F and G. So there's F and G, F and G. Okay, so there we have it, guys. That there is the elevation drawn and the plan view drawn. So it says here, draw the given plan and elevation of touchscreen A, B, C, D. We've drawn the elevation, we've drawn the plan. Perfect. Now, part B. It says here, determine the horizontal and vertical traces of the oblique plane that contains the touchscreen A, B, C, D. Now, what's helpful here is, technically, this is an oblique plane. It's a surface, okay, that's inclined to both the vertical and horizontal plane. I want to find where those this oblique plane would cut through the vertical and horizontal plane to find the traces VTH. Now, what's helpful here is the horizontal trace in this case is extremely easy to find, because the horizontal trace is technically where the line AD is actually already on the ground, because A is on the ground, D is on the ground. That is 2 points on my trace, therefore I can put in my trace. So the horizontal trace is simply a line where AD would simply extend all the way up to the XY line. So all I'm going to do with that is I want to extend it all the way. So in this case, I just need to extend out my XY line as well. Okay, so I've now found what's going to be called my HT. Draw that in there. I'm going to put them in red just for demonstration purposes today. So that is my horizontal trace, because that is where the oblique plane, ABCD, is actually interfering or intersecting the horizontal plane. Now, I'll extend out this guy. And once you have one of them, it is quite easy then to find another, the vertical trace. So that's my XY line. And if I was to label that then, put it in red, that is my HT. So T goes here, H down there. So that's my horizontal trace. Now I want to find my vertical trace. Once we have the horizontal trace, it's easy enough to find the vertical trace. I can use any points outside of A and D. So I'm going to use either F and G or B and C. I'm actually going to use B and C. So all I want to do is, parallel to the horizontal trace, which is that line there, all I'm going to do actually, sorry, don't need to do because B and C is already parallel to it. I'm going to extend B and C up to hit the XY line, where it comes up and it hits the XY line. I'm now going to project it up because that's where it's hitting the vertical plane. And as we would see, that in the elevation will be a vertical line. And all I'm going to do now from there is extend out B. And technically, where the two of them cross, that is a point on my vertical trace right there. Now that I have 1 point, this point here is already found, I can draw in my vertical trace. And there we have it. That there is my VTH. Okay, so that's the part B of the question done. Something there that would often stump some students, but That's it done. Nice and quick when you know what you're doing. Okay, determine the horizontal and vertical trace of the oblique plane that contains the touchscreen A, B, C, D. We have now found that. Okay, part number C. The bezel, black frame, of the touchscreen is offset by 16 millimeters from each edge. Draw the plan and elevation of the bezel. Now what they mean by that is essentially kind of like, I suppose, where we would see the screen and obviously there's a black outline protecting it. Okay, that's kind of what they're basically saying there. We have to be able to put that in. And we want to basically draw in that, I suppose, rectangle that's going to be fitting inside there like that. Okay. Now, the way we're actually going to do that, you could do part of it in the plan, okay, and I could measure in 16 millimeters from the edge AB, and I could get the line going here and here. The problem is I can't measure 16 millimeters this way, coming in that way, because that is looking down on top of it, and because it's inclined, okay, that's not actually going to be a true length in, and it would not be the same up here either. Okay, I could measure it here because the line AB, technically as I look down on top of it, okay, I'm still looking and that line there is perpendicular. I could measure in there. But really what we actually need to do here is we need to see the surface ABCD as an edge view. Okay, and the only way I can do that is by projecting up here an auxiliary. Okay, so I'm going to set up an X1, Y1 in the direction of the horizontal trace and an X1, Y1. And it will be going perpendicular because we're looking in this direction. I'm trying to see the surface ABCD as an edge view. So what I'm going to do is, with my set square there, actually, sorry, I'll just do it this way. So you can see how I'm using the horizontal trace to guide me. And all I'm going to do there is I just want a line. And once I have the line, I can kind of extend it on. So there we go. That there is going to be my X1, Y1. Okay, so that there is my X1, Y1. And now I'm going to project out all the points perpendicular to it. So A and D are already nearly out there because they're on the ground. And just parallel then, might as well bring up F and G. We may need it later on. And B and C. That'll come out there. Okay. Now, we've projected from the plan, normal rules of orthographic here. We've projected from the plan, we're going to take our heights from the elevation. Now, A and D are on the ground, so I'm going to see A and D as they come out here. That is going to be a point view of A and D. So, I'm just going to go, I'll call that A1, comma D1. Now I want to get the heights for B and C. So, projecting from the plan, take our heights from the elevation. B and C are at the same height. So I'm going to take that height there. I'm going to come down here, follow it out, and the X1, Y1 up, and there we have it. Up here, that there is a point view of B1, C1. And what's helpful here then is A connects to B, which connects to C, which connects to D. I'm now seeing that whole surface. Okay, I'm seeing the surface there, A, B, C, D, as an edge view. Okay, I'm seeing that kind of touch screen, the edge of it when I'm looking at it from the side. What's helpful here is it actually tells us the angle that we can see it at there as well. Okay, now that I've done that, what I can do is, because I have the true length of the side of it, let's say A, B, or technically D to C or C to D, however you want to call it, I can actually measure back 16 millimeters along that now to figure out that kind of little bezel. So, from B there, I'm going to come up here and I'm going to measure 16 millimeters back, which will give me a point right there. That there is where the bezel will be in the top surface. And I'm also going to do the exact same down here. Measure 16 millimeters there. So now that I've found technically where the bezel edges are in regards to the end view over, or sorry, the auxiliary view up here, I'm going to project them back to find them in my plan. Okay, so working backwards now. Projecting everything back parallel. That's where the edge is, right there. So that's that one. And I'll project this one all the way back as well. Okay, and if it doesn't come far enough, just extend the line on. Just make sure you're accurate with how you extend it. Okay, so I've got that edge and that edge. And as I said previously, we could also measure in 16 this way as we look down the top of it. So there's the 16 there. just occurred to me. Apologies there, folks. Just made a slight error, and I'll fix this really quickly. So it says here, the bezel of the touchscreen is offset by 16 millimeters from each edge. Draw the plan elevation of the bezel. I forgot about my scale, so instead of 16, I should have actually been measuring 8 millimeters there. So quick little fix there. Just going to rub out those lines. Fix it before we went any further. So instead of measuring 16, I did the method right, but instead of measuring 16, I should only have measured 8. So quick little fix there. Rub out those edges. Okay, I was thinking it was looking just a little bit too big. So instead of measuring 16, go back up here to the top left hand corner and measure 8 millimeters. So there's the 8. Measure the 8 there as well. Right here. And there are the edges that I have to project back. Apologies there. So now that I've got the 8, there we go. And the same with this one up here. And once I have that, as I did previously, I'm just going to extend it on. Okay, and likewise on this side, 8 and 8. So there's the 8, and there's the 8. Okay, and then simply drawing that in, parallel. So there's that one. Exact same down here with this one. Set it all the way along. Okay. I'm going to heavy that in my plan view, and then I'll project it up to the elevation. So we obviously have to draw those in relation to both views. So there's the plan. And that's how the bezel would appear. Okay, so that's the plan view of the bezel. Now what we're going to do is we're going to get the elevation. Okay, and to get the elevation, I could simply find the points up here. So I want to essentially find that line there. Okay, and on that line then I can find the point. So how would I find that line? Well, what's helpful here is I can just use the principle of the oblique plane. I could actually bring it up here, and you can see the line has already been brought up. You can see where it hits the XY line, right there. I could technically project it up. That would be the height of it, okay, on the vertical trace. Now all I'm going to do, just move some of my equipment here, apologies, from there, project it across. That will be the height of that bezel. This one here is already brought up, parallel to the horizontal trace. Where it hits there, bring it up to hit the vertical trace, and where it hits the vertical trace, project it across. Okay, so there's the bottom, there's the top one. Okay, the other way I could have done it, as you can see, where if I extend this out, where it hits the edge AB, could have brought that up. You'll see there, it ends up hitting right there on the edge, and then it would be brought in. Likewise with this one here, hitting right there, bring it in. So both would actually work there. Okay, so now that I've kind of got the edge and the edge, now what I need to do is find the bottom point. So the bottom point is going to hit right there. The top point is going to hit there. And what you'll actually find is if I connect the two of these points up, which I will in a second, it should be parallel to the point or the line AB. And likewise with this one, I'll project up as far as there. This one here on the right hand side, and there. And simply connect those up, and you can see that they're parallel. Okay, and once again, heavying that in the elevation. So very easy there. You can see how I nearly made an error with my measurements. Okay, I completely forgot about the scale for a second, and I would have done the method correctly, but I may have forgotten the scale, and you would lose marks or something like that. So just remember, every measurement needs to be scaled. And there we go. Okay, so there we have it. There is the elevation, and there is the plan view of when the bezel has been applied. Now we're on to part number 4. Okay, part D. It says here, the line FG in the plan and elevation, which is this line here, in the plan and elevation shows the hinge position of the kickstand. So there's a little kickstand here at the back. The angle between the kickstand and the horizontal plane is 35 degrees when in its open position. So they give us a bit of information there. They're saying that the angle between the kickstand, which is this guy here, and the ground, so that angle inside there is 35 degrees. Okay. Firstly, part 1, draw the plan and elevation of the open kickstand, and then it says determine and indicate the true angle between the touchscreen ABCD and the kickstand. Okay, so we have to draw that in. Now, essentially, the only way I can actually draw that in is when I see the ABCD as an edge view and I'm looking in from the side of it. That's the only way I'll be able to see the true angle, which is that 35 degrees. Okay, and we've already had that done here in the auxiliary view in the X1, Y1. I have AD down here on the ground, I've got BC here, and remember F and G, if I bring them up, that is where, right there, that point right in there is where the hinge is going to be for F and G. Now in this case, I'm going to call it F1, comma, G1. Now, the X1, Y1 is representing our ground in this case, so it tells us already the angle between the kickstand and the horizontal plane, the ground, the HP, the horizontal plane is already here, that's the ground, that line there, the X1, Y1, is 35 degrees when it's in its open position. So all I need to do is, I need to come along here and I need to do an angle of 35 degrees going like that. Okay, so I need to create an angle of 35 degrees. So what I'm going to do is, I'm going to come out, I'm actually going to do it right from this point here. I'm not saying that's the point of where it's going to be, I'm just using it to create the angle. And I'll create the angle 35 degrees and make sure it goes through F and G. So from there, I'm going to put my protractor on this point. I'm going to put the 0 here on the line. Make sure the other 0, and you can see the 90 degree one is going up there. And I'm going to read around to 35 degrees. 10, 20, 30, 35. Now, that line there, that's not the line that I want, but that's the angle that I want. So, now all I'm going to do is, I'm going to do the angle that I want, but going from F and G. So, parallel to that, I just created the angle from F and G. There we go. And there is my kickstand. Because what it told us was the angle that it makes, let's extend that there, the angle that the kickstand makes with the horizontal plane is an angle of 35 degrees. And that's the angle created inside there. So now that I've got the angle, okay, I've actually got F and G, I've got 2 points here that are now on the ground. What am I going to do with those? I'm going to bring them back. Okay, and I'm going to redraw that in my plan view. So projecting backwards like we've previously done. So parallel. Make sure I'm accurate here now. Now this question, if you knew what you're doing, could actually be done very quickly. So that's where the 2 points are on the ground. So there we have it. They'll have to be somewhere along there. And in reality, it has to be the same width. So all I'm going to do with those is, I'm going to project them out. Well, that one's already gone out there. So you can see it's gone out here like that. This one just needs to be extended out as well because it has to be the same width as the actual touchscreen. So all I'm going to do is draw that in. So this has gone a little bit wider now. Okay. So there I have it. Now those 2 points, this one and this one, are both on the ground. So if they're on the ground, I need to project them up to the elevation as well. So this point here is on the ground. And this point here is on the ground. Now where do they connect up to? Well, this one here connects up to F. And this one here connects up to G. And I need to draw them in. So that one there is there. And this one, we wouldn't see it. So we're going in as, that's like my kickstand there. That goes in as hidden detail. Okay. So there we have the first part. Draw the plan and elevation of the open kickstand. And you can see here we had to use the auxiliary view over here. Now part 2, determine and indicate the true angle between the touchscreen ABCD and the kickstand. So the true angle between the touchscreen ABCD and the kickstand. Now that's easy enough actually. They're just asking you to determine. You kind of have it done already because we've already drawn over here. Determine and indicate the true angle, so the dihedral angle between the touchscreen and the kickstand. I need to see the touchscreen and the kickstand as an edge view, okay, and I see both of them as edge views over here already. So where is the true angle? The true angle, technically you could take two of them. I'm going to say it's this angle inside here. So that angle inside there. Now it says determine and indicate the true angle. Determine and indicate. So what I'm going to do is I'm going to use my protractor. I'm using my protractor. I'm going to put it onto the line. I'm measuring that angle. So for here now, it's telling me 90, and it's telling me it's 100 degrees. Okay, so I'm going to say true angle between A, B, C, D, I'll just call it that, and kickstand. So there is the true angle inside there between the surface ABCD, the touchscreen part, and the kickstand at the back. Now, if this is 100, then this would be 80. So technically, I assume both of them would work if you marked one or the other. But usually, it makes sense that we probably do the angle between on the inside space, because obviously it has to close it. Okay, so there you have it, folks. That there was the oblique plane from the 2022 exam. You had to draw the given plan and elevation at the start, then determine the vertical and horizontal traces. You could see how quickly that was done. Okay, then we had to get the bezel, and I nearly made a slight error on that by not changing up the scale, okay, of it, or changing up the measurement based on the scale. It was half of 16, so I measured down 8 and up 8, brought that back, and then I was able to measure in 8 and in 8, and then get it up to the elevation. And then we had to put in the kickstand, so we got the angle of 35 degrees, and we did it off of F and G because that's where the hinge is. So that angle in there is 35. Projected it down to the plan, up to the elevation, and then we determined the true angle. So that question, quite easy to do when you understood your way about it. Okay, there you have it, folks. That there was question B3 from the 2022 exam. Hope you found that helpful.